Guys, so in the last video, I was cut off a little bit. My phone has been acting up. I guess my Obama phone or my Metro PCS is not that technologically advanced. I apologize for that. So I was explaining to you guys here, this last part here, that in order for us to convert this 15x to the third y to the first to the LCM of 60x to the third y to the second, we multiplied this 15 by 4y to the first. So 15 times 4 gives you 60. X to the third doesn't have any other x variable to multiply with, so we just bring it down. And then this y to the first multiplied with this other y to the first gives you y to the second. Okay, thank you. Okay, guys, so in chapter 14, we're going to be bringing in or tying in the concept of looking for the LCM or the common denominator and applying it to the addition of fractions. So just to recap or to remember or to review that whenever you have two fractions, in order for you to add them, the first thing you have to find is the common denominator. So in this case, since both of these fractions have a common denominator of 7, we can just add the numerators and it'll be the answer as 3 over 7. Let's say if we had 1/4 plus 3/8, we have to find the common denominator here between the 4 and the 8, which in this case would be 8. And we would have to multiply this 4 by 2, right, to make it 8. And whatever you multiply the bottom, you have to multiply the top as well. So then this 1/4 becomes 2 over 8 plus 3/8 because the 3/8 already has a common denominator, and we just proceed in adding only the numerators as 5/8. And we would proceed in reducing as needed. In this case, you wouldn't. I'll call this example A1 here, and we have original A. So how do we apply it to monomials now? So in this case, here we're looking only at numbers where we don't have any variables in the denominator. We'll get to those in a second. So for example, here we're trying to find the common denominator between 16 and 24. It's actually 48. 16 times 3 gives you 48, and 24 times 2 gives you 48. So again, we multiply times 3 times 3, or actually just put a parenthesis, I'm sorry, so we don't get confused. And we multiply this by 2 and also by 2. Again, remind yourselves, I'm sorry, that you're multiplying the entire fraction by a fraction of 1, or the equivalent of 1. So in the top number here, we have 3x times 3 gives us 9x over 48. The bottom second fraction, we have 2 times 5x to the second, which gives us 10x squared. And on the denominator, it'll give us 48. So now how do we add this? We just combine this term with this term, right? And we know that our common denominator will be 48. So given that 10x squared cannot add or cannot be collected with like terms of 9x, we would just write 10x to the second plus 9x. Remember, we cannot add and make it 19x to the third. That doesn't work that way. Okay? In order for you to collect like terms, they have to have the same variable and elevated to the same exponent. So in this case, your answer would just be that right there. Okay, now let's look over here at the third example that I have. In this example here, I have x minus 2, the fraction x minus 2 over x plus 3 plus x plus 7 and x plus 8. So we need to look for the quote-unquote what's missing as far as the denominator goes in the first fraction, so that it would have something in common with the denominator in the second. So if you think about it, the x plus 3, in order for it to have something in common, it also needs to have an x plus 8. And the bottom one, it's missing an x plus 3, right? So thus, our common denominator would be x plus 3, x plus 8. That's our common denominator. Okay, so then if we multiply it in the bottom part of the fraction by x plus 8, we multiply x plus 8 on the top one. And in the second fraction, given that we're multiplying the current denominator by x plus 3, we have to multiply that same numerator by that same binomial x plus 3. So here's what's going to happen. The bottom, the denominator on the first one is going to be just x plus 3, x plus 8. And same thing on this one as well, x plus 8, x plus 3, or x plus 3, x plus 8. Okay, however, let's go ahead and distribute, do the FOIL method. So by doing the FOIL method, we have x times x gives us x to the second. I'm going to erase this top part here, that way we don't get it confused, okay? So let me just erase it here. Okay, so x times x gives us x to the second. X times 8 gives us positive 8x. And then we have negative 2 times x gives us negative 2x. And then negative 2 times 8 gives us negative 16, right? Okay, for the second fraction, again, we do the FOIL method, which gives us x to the second plus x times 3 gives us 3x. And then we have 7 times x gives us 7x. And then positive 7 times positive 3 gives us positive 21. Okay. So as you can see, it's just a series of expansions on the problems that we learned in the previous chapter, chapter 13. So here we're going to have collecting like terms in the middle here. It'll be x squared. Positive 8x minus 2x gives us positive 6x minus 16. And then what I'm going to do, just to make it easy to collect like terms, we're going to just copy the second numerator from the second fraction, and I'm just going to put plus x to the second from here. And then look, 3x plus 7x, I'm going to bring it up here to make it plus 10x. Okay, so this 3x plus 7x, I collected it together and I made it 10x. Okay, and then we have this plus 21, and I'll just bring it up here, plus 21. And again, we have the common denominator of x plus 3 times x plus 8. But first, let's go ahead and look at this long mathematics sentence here. What else can we collect as like terms? So look, we have an x to the second here and an x to the second here as well. So that makes it 2x to the second, and let's cross it out, that way we don't get confused. Then we have positive 6x and positive 10x, so that makes it plus 16x. Let's cross it out, that way we don't get confused. And then we have negative 16 plus 21, which gives us an answer of positive 5. Okay, now we're going to bring our x plus 3, x plus 8. And this is your final answer. You can do the FOIL method on the bottom as well if you wish, which would just be x to the second plus 11x plus 24. Whichever one of the two. If you want to leave it as x plus 3 times x plus 8, or if you want to replace this by x to the second plus 11x plus 24, I am completely okay with that if you wish to practice your FOIL method even further. Okay, so in this next chapter or section, 14.5, we're going to be looking at subtracting rational expressions. We section 14.4, we did addition. This is subtraction. One thing to keep in mind, guys, that I always mention to you is that this negative, keep that negative, keep track of it, because again, it's going to affect the end result if you do not carry it throughout your solving the problem. So just like in addition of fractions and subtraction of fractions, we also have to have a common denominator. So here we have to locate the common denominator between x minus 4 and x plus 4. To make it easier, this first fraction is missing an x plus 4. So we're going to multiply the denominator of the first fraction by x plus 4, thus we have to multiply the numerator by x plus 4, and our common denominator will be x minus 4 times x plus 4. Okay, and so for the first part of the fraction here, what we'll do is we're going to do the FOIL method, which is x times x gives us x to the second, and then x times 4 will give us positive 4x. 2 times x gives us 2x positive, and then 2 times positive 4 gives us positive 8. Okay, now the second fraction itself, x plus 1 over x plus 4, in order for it to find the common denominator, which is missing x minus 4, we're going to multiply the denominator by x minus 4 and the numerator times x minus 4. And again, we'll do the the FOIL method. So this gives us x to the second, and then it gives us negative 4x, and then we multiply 1 times x, which gives us 1x or positive x, and then 1 times negative 4 gives us negative 4 here, and x minus 4, x plus 4. Okay, so I'm just going to continue working to my right. So the first fraction, we're still working on the first piece of the fraction. So we'll collect whatever like terms are similar. In this case, this gives us x to the second plus 6x plus 8. And what I'll do is I'll just do this. Look, I'll put it all over the common denominator, x minus 4, x plus 8. And then this next fraction here, in the next fraction, once we did the FOIL method, we're going to collect whatever like terms. And what I'll do here is, let me grab a red marker so we can keep track of this here. So look, I'll put the minus that is located here from the subtraction. I'll put it as a big negative, and I'll put it in front of the parentheses. That way you see what's going to happen right now. Okay, so now we have this second fraction. It's going to be x to the second, right? We're collecting like terms, and then we have negative 4x plus 1x, so that gives us negative 3x, and then that negative 4, we just bring it up here. Now, what happens now? This negative in front of this trinomial is going to be distributed to every single term in front of it. So that means that your signs are going to be changed. Okay? So here's what's going to happen now. So we have x to the second plus 6x plus 8 minus x to the second plus 3x, right? Because they went from a negative times a positive becomes a negative times a negative becomes a positive, and a negative times a negative will give us a positive here. Now, again, keep in mind that we still have the common denominator, okay? So I'm just going to simplify the second fraction here. I mean, the second set of terms. So look, we have positive x squared, negative x squared. So these two, I'm going to use the red marker. Give me 1 second so you can see what happens. So we're simplifying, okay? So we're going to cancel out this positive with this negative. We're going to collect the terms, 6x plus 3x, so that gives us 9x, and then positive 8 and positive 4 gives us positive 12. And again, this was just simplifying the new numerator, right? Once we collected the like terms. And remember that our common denominator is going to be x minus 4 times x plus 8. Where did I get the x plus 8? No, x plus 4, not a plus 8. Sorry, guys. So it's x minus 4, x plus 4. I got confused with the 8 here and I put it positive 8. But look, in the original problem is x minus 4, x plus 4, x plus 4, x minus 4. Okay, so it was positive 4, not 8. I apologize if I confused you guys there. Or if I threw someone a curveball and they said, hey, wait a minute, how'd you get that 4 to become an 8? It wasn't by the magic of television, guys. I'm sorry. It was my mistake. I didn't carry my numbers correctly. Okay, so this would be our final answer. However, actually, no, I take it back. This wouldn't be the final answer. Is there anything that we can factor off of the top one? Yes, we can. We can factor out a 3 from this number up here. So then look, it'll be, if you factor out a 3, it'll give you 3x plus 4, so you wouldn't be able to factor anything out. So no, never mind. I take it back. That is our final answer. I was trying to give you guys this. Look, 9x plus 12. If I factor something from there, what do they have in common? The 9 and the 12, it would be a 3. So this will give us 4x. I'm sorry, 3x plus 4. But I was trying to cancel to see if I could cancel this term with our common denominator, but it wouldn't. So that's why I decided to retract myself, and that is our final answer. So it is not complicated, guys. If you keep track of your positives and your negatives, it is fairly easy. Lay it out. Don't be shy about making a diagram, or don't be shy about writing it all out. Don't try to cut corners, because in cutting corners you might end up messing up the equation. Okay, so I'll give you guys a second to absorb and marinate your mind with all of this mathematical stuff. Like Edward James Olmos would say, you burros have math in your blood. All right, so there you go. Okay, guys, so in this final section of chapter 14, it's titled Solving Rational Equations. And while I was writing up this thing on the board, I realized that I might have called some of you guys burros. It wasn't my intention to disrespect you guys. It's just that I was trying to be funny and quoting Mr. Jaime Escalante, like in the movie Stand and Deliver, where he tells his students that math shouldn't be difficult because math should be in their blood. So if anybody took it as an offense, I apologize. It wasn't my intention to call anyone a burro. Okay, in this next section, I have mentioned to you guys in the past that it's the convenience of canceling or clearing out fractions, and this is where that comes in handy. So here in the first example that we have, let's find the common denominator between the 4, the 8, and the 12. In this case, if we think about it, 4 times 6 gives us 24, 8 times 3 gives us 24, and 12 times 2 gives us 24. So the common denominator here would be 24. So if we multiply the entire problem here by 24, it could clear out that fraction. So again, look, how many times does 4 fit into 24? It's 6 times. So 6 times 3 gives us 18, right? And then I'm going to just actually erase that, so I'm just showing you the process, okay? So then we have, how many times does 8 fit into 24? It's 3 times, right? So 3 times 5 gives us 15. And then here on the right-hand side, how many times does 12 fit into 24? It's 2, so that 2 times x gives us 2x, and then we just go ahead and proceed in solving that problem. Okay, I'm going to bring it up to this upper part here so we have more space. So we'll add 15 plus 18. It gives us 33 equals 2x. And in isolating or finding the value of x, we're going to do the opposite operation. So inverse operation, I'm sorry, which here is multiplying. So we'll divide by 2 and we'll divide by 2. So in doing so, the 2's cancel out and we're left with x, which is the same thing as 33 halves. You can leave it as 33 halves, or you can go ahead and do the mixed number, which would be 16 and 1/2 equals x. Whichever one of the two answers is perfectly fine. Okay. Now let's look at this next example here. We're trying to find a solution to this rational equation, and I think I've mentioned it to you in the past that whenever you have two fractions or two proportions and they are equal to each other, the fastest and most efficient way to solve it would be to do a cross multiplication and then set them up equal to each other. Okay, I think we did this in the previous class where I was telling you guys how to do the proportion and how to find the value. So in this case, yeah, you're gonna have to find the common denominator, but the fastest way is just whenever you have two proportions equal to each other, cross multiply and solve for the variable at hand. So let's go ahead and do x times 1 gives you x is equal to 1 times 6 minus x, so 6 minus x. Now, those of you that were in my class last term, remember that I've mentioned whenever you have variables on both sides of the equal sign, bring the smallest number of x's or variables to the side that has the most. Even though it's 1x here, this is one positive, this is one negative, right? So the negative 1 is the smallest, and we're going to do plus x. So when we combine the terms here, you have 2x equals 6. We proceed in isolating the value of x by dividing by 2 on both sides of the equal sign, and 2 divided by 2 becomes 1, so x is equal to 3. Okay, so again, when you have two fractions that are equal to each other and they're asking you to solve, cross multiply and set them equal to each other, and then just work with solving for that specific variable. Okay, unfortunately it doesn't get as easy as that, guys, as you guys can see here. However, if we take a look at this problem, one thing that we got to keep in mind is this. You guys have gone over in the previous chapter the difference of two squares. So technically this x or x to the second minus 4 is the same thing as x plus 2, x minus 2, right? So think about it. Excuse me. So if I want to just for simplicity's sakes, what I'm going to do is I'm going to just make it x plus 2 here, x minus 2, right? And now, in order for me to cancel that fraction, I'm going to erase the letter c here. That way it'll give me space that I need. Okay, so if I want to cancel my fraction, what I'll do is I'll put a parenthesis here big enough, and I'll say that my common denominator is going to be x minus 2 times x plus 2, right? That's what appears to be. So look, I'll do x plus 2, x minus 2, okay? That's my common denominator, x plus 2, x minus 2. That's an x right there. I apologize. Okay, so then look, we're going to multiply this x plus 2, x minus 2 times the first term, but the x minus 2 is going to cancel out with this denominator here. So technically the first term here will become 4 times x plus 2, right? Because the x minus 2 got canceled out. Let's move on to the second term. X plus 2 will cancel out with the x plus 2 here. So we're technically multiplying this 1 times x minus 2. So this would be plus 1 x minus 2. And now here comes the easy part. Think about it now. We have x plus 2 times x minus 2, which is what in technicality this x squared minus 4 is, right here. So we are going to be left on the right hand side of the equation with only the 26. Okay, so let me go ahead and distribute now the terms that are in front. So look, 4 times x gives us 4x. 4 times 2 gives us positive 8. Plus, this is 1 times x, or just x minus 2, equals 26. Okay, to recap again, guys, please, this is very, very important. I don't want you guys to get confused and say, oh my goodness, this is gonna make me by the end of the lesson here or the chapter, I'm going to end up with the professor's haircut. Those of you that might not know me personally, my head is shaved most of the time, so I don't want you guys to lose your hair over this stuff. So we're just looking at the common denominator here, which is x minus 2 times x plus 2. We realize that x to the second minus 4 is the same thing as the common denominator that we need. We multiply by that common denominator to clear that fraction, and we ended up with these simplified terms. Now we collect like terms. We have 4x plus 1x gives us 5x, and we have 8 minus 2 gives us positive 6, which is equal to 26. We work in isolating or solving for x, and we do the opposite operation of plus 6. We do minus 6. Whatever you do to one side of the equal sign goes to the opposite side. So we have 5x equals 26 minus 6 gives us 20. And then again, right, we are continuing in the process of isolating that x. So we divide both sides by 5. And x is equal to 4. So all of that mumbo jumbo that we did right now gave us the value. Okay, so this is problem C here. That way we don't get confused with where does it stop or where does it end. Okay, so there we go. Whatever's in that little box is what we need to look at. Okay, so again, guys, do not be afraid that a mathematical problem looks too big. An analogy that I used to use with my students was that picture a steak in front of you as you're having to have dinner. You're not going to eat the entire piece of meat in one bite. You're going to cut it up into chunks and enjoy it. Again, some of you guys might not enjoy math. Others of you might find it interesting and challenging, but at the same time, the good kind of challenge that's going to make you feel that you accomplished something. So here we have, again, the common denominator was x plus 2, x minus 2, which we got from x to the second minus 4. And we multiplied that into the entire equation to clear that fraction, okay? And this concludes our chapter 14.